Hello everyone, welcome to this comprehensive guide for building a real-world weather application using modern JavaScript practices. So in this tutorial, we will be developing a weather app that fetches and displays current weather data, and it gives data such as temperature, weather description, wind speed, sunrise and sunset times. So we'll be using Open Weather Map API to retrieve the data and create a user-friendly interface using HTML, CSS and JavaScript. So this weather app, in which the users can input the name of a city to receive the detailed weather data, and it has got these features. So city search will allow the users to input a city to fetch the weather data, and weather data display shows the temperature, weather conditions, humidity, pressure, wind speed, sunrise and sunset temperature, and it has got dynamic weather updates on the page without requiring a page reload. So let's continue with the objectives. So technologies used is again HTML, CSS and JavaScript, and modules. There are a few modules. The first module is main.js, and it manages user interactions and updates the UI based on data fetched from the API. And weatherservice.js, this interfaces with the Open Weather Map API to fetch weather data from a which is available for public consumption, which I will show you shortly. And there is another UI renderer.js which processes and displays the weather data on the web page. And the API integration uses the Open Weather Map API to get weather data in real time, and it converts the received data to a user-friendly format and handles time zone adjustment. Now, before diving deep into the project structure and see the actual code in work, let me introduce you to the home.openweathermap.org. This is the Open Weather Map website that we will be using, and I have created. You need to create a free account. I have created one, and here you can see I have got these my API keys. So if you are logging for the first time, you'll go to your profile after logging in, and then you'll be able to create your own user API keys, which is very important to actually communicate with the API. So this is my key that I could edit, but I'm fine with that. And the key name is active, and this is the key which I have already copied on my clipboard to be used with the Visual Studio Code. Okay, then let's get back to our slideshow. And the project structure is, we have got an index.html, which is the main HTML file, and it has got a style.css style sheet for applying style, application styling, and we have got a scripts folder which has got a main.js which handles the form submissions and updates UI, and a weatherservice.js which fetches the weather data from the API. This UI renderer.js, it updates the UI with weather data. Now, before looking into the markup and the CSS and JavaScript code for each of these modules, let's first switch over to Visual Studio Code and start building your application. So on this module demo, I will create another folder. So on module demo, I will create this folder, new folder, and name this real world demo. So onto this real world demo, I will create another folder, the subfolder within the real world, which is supposed to hold all the scripts, JavaScripts. Okay, so new folder again. All right, and onto this new folder, I will create this main.js, UI renderer.js and weather service.js. But first of all, let's create the index.html on the index.html on the root folder, that is the real world demo folder. So let me just highlight this and add a new file and make this, name this as index.html, and I will paste the code or markup on my clipboard, which is this, and save the index.html file. So if you quickly go through this index.html, so following the conventional head, you got this body, and the head includes a link to a style sheet, which we will now put. And let me quickly explain. And this header will have a title H1 weather app, and there is a section which has got an ID within the main and end main section of the body, and ID will be search, and this is checking the weather, check the weather, and then we'll create the form, a weather form with an input type text, a freeform text, and an ID of city input and a placeholder enter city name, which is required. Okay, is a validation. Now the button will be, button type is submit, and on the button it will be, the name of the button is get weather, and on the section ID weather display, this is the form element, and this is the element that displays the weather information, and it has got a weather container with an ID of weather container, weather dash or weather hyphen container, and weather details will be dynamically loaded here. And that will be the beauty of our project, that it will be displayed dynamically. All right. All you have to do is to create the placeholder for displaying the dynamically loaded weather details. And this is the footer. And we have put the scripts over here, and I'll have got a source is script/weather service.js and script/main.js, which are yet to be written. All right. So we'll next put the CSS style sheet, and then I'll come to the scripts. So let's now create a styles.css, a CSS style sheet, and this will be within this within the root folder, real world demo. So I've highlighted real world demo and click on new file. So styles.css, and in the styles style sheet, I'll paste this code. So it's just a standard style sheet CSS file. You can see that there is a body section, and it is a body section got a font family. You can always change this, play around with this body, margin 0, padding 0, and there is a color. This is the color, black color, nearly blackish color. Okay, and the header background color is this bluish color, and this color is white. Set the color of the elements text, and then padding is 1 rem, and text align is center. Okay. Now to have a bit of an understanding for those who require, so this rem by default is the font size of the root element or the HTML element, which is 16 pixels in most browsers. So if you don't explicitly send the font size to the root, for the root element, 1 rem will be equal to 16 pixels. So the size in rem is calculated by multiplying the rem value or rem value by the root element's font size. For example, if the root font size is 16 pixels, 1 rem is 16 pixels. All right. So this is the example usage. Padding is 1 rem, and again the main is 2 rem. Now, since rem is based on the root element's font size, it ensures consistent sizing across different elements on the page regardless of their nesting. we can see the different sections. I have got a different style sheet elements. Main element of the padding of 2 rm, maximum width of 800 pixels, margin is auto, and it is automatically selected dynamically margin. So margin bottom is again 2 rm, and for the weather form display is flex type, and for the city input flex equals 1, and let's see what is this flex display. So when you apply display property as flex to an element, it becomes a flex container. All of its direct children automatically become flex items. The main axis is the primary axis along which the flex items are laid out either horizontally or vertically, and the cross axis is perpendicular to the main axis. And so flex is 1. It means it tells the flex item to take up an equal share of the available space in the flex container. So all other sections of this style sheet, button hover with the background color of this one, bluish color, dark blue, and weather display with the background color of white, and padding of 1 rem, border radius, and box shadow. Box shadow is a special property of style sheet, and it means, so this CSS property, it adds a shadow effect around an element, giving it a sense of depth or elevation, as if it's lifted above the background. And there are a few elements over here. This is the horizontal offset, this is the vertical offset 2 pixel, and then there is a blur radius 5 pixels, and then spread radius, and then color. Now in this example that I have just provided, this box shadow, this within this properties there is no spread radius. Okay, so this is the horizontal offset, vertical offset, blur radius, but there is no spread radius. So spread radius is 0 in that case. If it is not there, it is omitted. So this means that the shadow doesn't spread or contract beyond its original size. So now, having made the index HTML and style.css, we will write these JavaScript files. So let's start with the first file, which is weather service.js. So create a new file. Weather service.js, and I will paste the code over here. So this is this part. I will paste it from my clipboard. So now before moving further with the explanation of weather service.js, let's run through our PowerPoint slideshow about what we have learned in this project structure in the project files. So first of all, you have seen the HTML. HTML is the index.html file. So it has got the basic HTML setup with header, main content, and footer, and includes a form for user input and a section for displaying weather data. And it has got the link to style sheets and JavaScript files. So we have also seen the CSS style sheet, which is the general styling for the body, header, main content, and the footer. And it has got specific styles for form and weather display sections. And it ensures a clean and professional appearance. And we have already seen the VS Code editor for the CSS file contents. Now, next is we have got main.js, weather service.js, and UI renderer.js. So now, before main.js, I would like to show you the weather service.js, because weather service and the UI renderer module will be included in main module. So better to get through the weather service module first. So this is the weather service, which has got an API key of this value. Now this API key I have discussed earlier, and to recap, it comes from openweathermap.org API keys, which we have already seen. Okay, so if you are logging in for the first time, then if you click on your profile and expand it, then in this case I have got already my API keys. So in your case, it will come up with a screen where you should be able to make your set of API keys. Okay, and then put that value in the Visual Studio Code. So back to Visual Studio Code. Now what this API key is used for, it is actually we are writing a get weather and passing the city name here, and we are, because we intend to export this function, and then what this function is doing, that it is returning this value. It is fetching from this URL api.openweathermap.org/this, and then you're putting the city name, and it gets the city name from the form, and app ID is this API key. If it could fetch, then the response is written in the JSON format, and then data goes to data. Then data is followed. Now this part dot then response goes to response.json. This line processes the response object returned by the fetch. Okay, and this response.json method is called to pass the response body into a JavaScript object from JSON format. It returns a promise that resolves to this pass data. And response.json converts the raw response data, which is in JSON format, into a JavaScript object, so it can be easily accessed and manipulated. And then data goes to data. Data implies data. What it does is that this is the second then that takes the past JSON data from the previous step and returns it. Although it might seem redundant here, this is where you could add additional processing logic if needed. And the final return value, that is the data returned here, is the final output of the function, which is the JSON object containing the weather information for the requested city. Okay. So basic purpose is that this code retrieves weather data from the OpenWeatherMap API for a specified city. So it fetches the weather data from the OpenWeatherMap API, returns the data in JSON format, and we have already seen the module contents. Now we come to the UI renderer.js. Let's go back to our Visual Studio Code and click on scripts again. New file. UI renderer.javascript. And this is the code for the UI renderer, which exports a function display weather. It takes the weather data, and what it does is that it creates a few variables which are actually constants. You fix the value and you are not able to change it. Okay, so temperature in Kelvin, it actually gets the temperature from this branch, weather data dot main, and temperature, if it is available, then it puts this value, otherwise it puts the value not available. Okay, and then similarly it assigns the value to all other variables like description, weather data dot weather data dot main. So if we debug, then we'll see that these branches can be expanded to get you all these details: temperature, feels like, humidity, pressure, speed, degree, and visibility. Okay, and then because I need the temperature to be displayed in degrees centigrade, so this is a conversion from Kelvin to degrees centigrade, and similarly the feel like in centigrade is also changed by this formula. So temperature in Kelvin minus 273.15 dot to fixed to 2 places of decimal, and if it is not available then we put the value NA. N/A similarly for fields like C is the centigrade value of these two. And then this part actually gets the time zone offset in seconds, because I want the time to be in the displayed in the local time of that place. Say if it is New York, it should be displayed in New York time, not the location where I am using the application from. Okay, and similarly we get the sunrise UTC and sunset at the UTC, and by this formula, and then we create our local sunrise time and sunset time by this formula. Okay, and now let's go through a bit of explanation about these 4 lines in particular. So here what this line does, weather data dot sys question mark dot sunrise, it uses optional chaining, question mark dot, to safely access the sunrise property within the sys object of the weather data. If weather data dot sys is undefined, or if the sunrise doesn't exist, the result will be undefined, preventing a potential error. And the sunrise value is a Unix stamp in seconds that indicate when the sun will rise in UTC, or coordinated universal time. Now what this new date says, if sunrise exists, okay, if it is true, this side after the question mark, this expression multiplies by the timestamp by 1000 to convert it from seconds to milliseconds, which is the format expected by the JavaScript's date object. So the date object expects milliseconds, so it has to be converted by multiplying the seconds into milliseconds by multiplying it with thousands. Okay. Now this creates a new date object representing the time of the sunrise in UTC, and sunrise UTC and sunset UTC. These variables are there to store date objects from the UTC sunrise and sunset times respectively, and if the sunrise and sunset values are not available, they are put null. And weather data dot sys dot sunrise, this value will check if the sunrise property exists, this side. If it does, it creates a date object. If it doesn't exist, it creates a null object. It assigns null to the variable. Okay, and then let's see, this is the local time conversion. So this is this part, sunrise UTC dot get time. This get time method returns the number of milliseconds since the Unix epoch. That is, Unix epoch starts from the 1st January 1970 for the sunrise UTC date object. And then this time zone offset seconds multiplied by 1000, it converts the time zone offset from seconds to milliseconds. The time zone offset represents the difference in time between the UTC and the local time zone of that place that we are searching for. Okay, so why we add the offset? The purpose of adding the offset is to convert the UTC time to the local time. So it creates a new date object representing the local sunrise or sunset time. And now, so what was that total process? Extract UTC times from the weather data, convert these UTC times to local times using the city's time zone offset, and stores the resulting sunrise local and sunset local. Now finally, adjusted format to force UTC with adjusted offset. Okay, so options, we store hour 2-digit, minute 2-digit, and second 2-digit. Time zone is UTC. And then to this sunrise local and sunset local values that we have calculated in the above 4 lines, we call the locale time string, and we add this value GMT time zone offset second divided by 3600 greater than equal to 0. So this is also important to know. Now let's break down these 2 lines of code. So this sunrise local not equal to NA, this checks if the sunrise local value is not available. If not available value is there, I mean if it is NA value, it indicates that the local sunrise time was not available or could not be calculated. The purpose of this conditional to determine whether the code should proceed with the formatting the time or return not available. Alright, so you can easily figure this out from this part of the code. So if this is not equal to NA, then you do this part, okay, this whole part which I am going to explain, or if it is equal, then just spit out NA. Okay, so now let's see sunrise local to locale time string. This method converts the sunrise local date object to a string representing the time formatted according to the specified locale English US and options. And what is the options? This variable is, it includes the formatting options like hour, minute, second, and time zone, which controls how the time is displayed. Okay. Now, this GMT time zone offset seconds divided by 3600 greater than equal to 0, question mark plus within single quotes or empty string, percentage time zone offset seconds divided by 3600. All of this expression, this part of the code calculates and appends the GMT offset time to the time string. So time zone offset seconds divided by 3600 converts the time zone offset from seconds to hours. And greater than equal to 0, question mark this part plus within single quotes, then colon, empty space. This determines whether to prepend a plus or nothing based on whether the offset is positive or negative. This adds the time zone offset to the formatted time string. For example, GMT plus 5 or GMT plus 12 or GMT minus 4, something like that. Okay. To locale time string, output is concatenated with the GMT offset to create a full string that shows both the local time and the corresponding GMT offset. For example, 6 hours, 3 minutes, 55 seconds AM GMT plus 5. We'll see the result when we run the application. And sunrise local not equal to NA, and this is the ternary operator. Okay, so if sunrise local is valid, it formats the time. If it is not valid, it returns not available, NA. And sunrise local string and sunset local strings are the variables that store the final formatted strings for the local sunrise and sunset time, respectively, including the time zone offset. So in summary, this whole code formats the local sunrise and sunset time to a readable string that include both the time and GMT offset, making it clear in which time zone the times are relevant. So this is a little bit complicated stuff to understand, but if you go through the lecture and see the code quite a few times, then you can understand. So the whole process is, it is to check if the time is available and format the time to a string using two local time string and add the GMT offset to the time string, store the resulting sunrise local string and sunset local string, or return not available if the time was not available. So now we have gone through UI renderer, which updates the web page with weather data, converts temperature from Kelvin to Celsius, and formats sunrise and sunset times to local time. And we have seen and gone through the discussion and the VS Code editor. Now finally, before conclusion, we will see what the main.js looks like. So main.js in a nutshell, it listens to form submission, retrieves and trims the city name, and calls getWeather function and handles the response, and calls displayWeather to update the UI. So let's go through the main.js, how it looks like. So we'll create this file, new file. Main.js, and then main.js looks like this. This is the main.js. So it imports the getWeather from the weather service and displayWeather function from UI renderer.js. And this is the So one more thing that was left in UI renderer is that after calculating all of these variables, we look into the weather container variable. It actually gets from the HTML document where it looks for this ID weather container, which is there in this first DOM object, DOM tree. It is available in index.html. So when it finds the weather container, get element by ID function, then it to the weather container's inner HTML, it puts all these details, temperature, fields like description, humidity, pressure, wind speed, visibility, sunrise, sunset. Else, if it doesn't find, then it logs to the console weather container element is missing. Now let's get back to main.js. So what it does, it imports these two functions from these two modules, and in this case it adds an event listener. So ensures that the script runs after the HTML document is fully loaded. Okay. And it prevents the default form submission behavior, prevent default, and it puts the city value after trimming it from the city input, and if the city value is available, then in the getWeather, which it has imported from weather service, and it passes that data directly to the displayWeather, or it catches an error fetching weather data, and in that case displayWeather is not available. Okay, the description unable to fetch data, and if city is not available, then it logs to the console. The city input is empty, and in this case displayWeather is again not available, like the previous case when it was unable to fetch the data from the weather API. So we have put everything together and we are ready to run the application. So how do we run this application? I have opened up index.html and I can open it with live server. Now I will explain what is this live server. This is just an extension which I got from the extension marketplace. I will show you. So enter the city name, say Delhi, get weather. You will get the current weather of Delhi. And if you click on any other city, say New York, it changes immediately to the current weather condition for New York City with temperature, feels like, and all other parameters like that. Okay. Now a couple of things here to note is in this display, you can see that I've got this sunrise and sunset for this city of New York as 6:07:54 a.m. Okay, it's sunrise is in the morning, GMT -4, and sunset is in the PM, GMT -4 again. Now this, as I was explaining, this has come from this part. Okay, so plus GMT time zone offset seconds divided by 3600. Okay, greater than equal to 0. This is appended with whatever time zone offset second you are getting. So it could be positive, it could be negative. Okay. So the same thing is valid for sunrise, sunset local string. And the thing is that, if you change the destination, say Auckland, so it becomes a GMT plus because it is ahead. Auckland time in New Zealand is ahead by 12 hours from the GMT time. And also, one more thing to note is that, if you see any cities, if you input any city, say Auckland, New York, New Delhi, whatever, the temperature and feels like and all of these descriptions for the weather information are bound to change because that happens from API. So you don't need to refresh anything. Okay, so if you get back to here, if you look into the extensions, this is the extension. So we have the installed extension. If you look into extension live server, so live server. So I have already had it installed. You can either uninstall or disable it, but it is already there. Okay. So this guide has provided a step-by-step approach to building a weather application that retrieves and displays the current weather data using Open Weather Map API. By leveraging JavaScript modules, we keep our code organized and maintainable, and you can further enhance this application by adding features such as weather forecasts or graphical representation of data, etc. Okay, and you can always, you're welcome to experiment with the code and tailor it to fit your needs.